Hi, and thanks for stopping by. This is a brief introduction of my research lab, Laboratory for Intelligent Communication and Networking, in the Department of Electrical and Computer Engineering at the University of Virginia. My name is Cong Shen. I am an assistant professor in this department. So let me start with who we are. Let me introduce the lab. We have 5 brilliant students working in this lab, and frankly, the lab is really all about its members. 2 of them, Chen Shuai and Yu Jia, are second-year PhD students. They have narrowed down their research to some specific topics. Chen Shuai is working primarily on multi-arm bandits and reinforcement learning, and Yu Jia is working primarily on machine learning for communications and distributed machine learning. Chen Shuai got his bachelor's degree from USDC, University of Science and Technology of China, and Yu Jia got her bachelor's degree from Tsinghua University and master's degree here at UVA. The other 3 students, Xi Zixiang, Li, and Kun, are all first-year students. They just got started here at UVA. They are taking courses right now, primarily, but they are also looking into different aspects of the research in our lab. Xi Zixiang is looking into more on, federated learning, especially over wireless channels. Li is interested in multi-arm bandit, more from the theory side. Last but not the least, Kun is interested in wireless testbed, as well as reinforcement learning for wireless network optimization. Xi Zixiang got his bachelor's degree from Tongji University and master's degree from Fudan. Li got his bachelor's degree from USDC, and Kun got his bachelor's degree also from Tsinghua University and master's degree here in the States from Texas A&M. As for myself, I got my PhD degree from UCLA under the supervision of Dr. Michael Fitz. After PhD, I spent a few years in industry, which influenced my research on wireless later on. I spent also a few years in startup companies such as Sparta Cloud Wireless, Selvus, and Xsense. Along this journey, I have been exposed to different aspects of wireless research, from physical layer to macro layer to upper layer, from testbed development, prototyping, field testing, to algorithm design, analysis, simulations, to standardization. I consider myself lucky to have the opportunity to work in a real world wireless industry and understand what is happening in the real world. This also has shaped my flavor and my taste in terms of wireless research. The photos you see here are actually a few among the many mentors I have met in my professional career. And I consider myself very lucky to have known them, to have received guidance and support from them. What do we do right now in this lab? If I have to summarize that in one sentence, that will be the following. We are particularly interested in communication and networking by machine learning for machine learning. And this is best illustrated by this simple diagram here you see in this slide. So there are 2 different fields. Machine learning is one area of research. Communication and networking is another area of research. Traditionally, these 2 fields have very little interaction, but this has changed over the last 3 to 5 years. On the communication side, the problems have become much more complicated, and conventional methods are becoming increasingly difficult to solve these problems. And as a result, communication engineers have started leveraging the advances in machine learning to try to tackle some of the challenging problems in communication and networking research. So we consider machine learning as a new set of tools for communication and networking research. On the other hand, machine learning research is really supported by various applications. Also, conventionally, machine learning research is largely motivated by research such as computer vision or natural language processing. But in the last few years, we have also seen applications and problems coming out of the communication and networking research that give a new spin for machine learning algorithm design and theoretical analysis. So we are also interested in developing machine learning algorithms and machine learning theory that are better tailored to the characteristics of communication and networking. Let me explain these two aspects a little bit more in detail in the next few slides. So first, let me talk about the wireless research. So what do we do here in terms of the wireless research? This is important because this really lays the foundation for everything we do here, from wireless to machine learning. And the philosophy in our lab in terms of the wireless research is best illustrated by this picture on the left-hand side. So we're not a pure theoretical group, and we're also not a pure experimentation group. We work in the intersections of these three elements of the wireless research: theory, simulation, and experimentation. So we generally start with an interesting problem, an important problem, and then we try to derive the theory aspect of our solution in terms of algorithm, in terms of analysis. And then we go to the simulation path, where we try to implement this algorithm in a simulation environment. We try to validate the effectiveness of our algorithm, and then we loop this with the theoretical development back and forth. Once we have a fairly good understanding of the theory, of the algorithm, of the analysis, and we would like also to take that into experimentation by implementing the algorithm in hardware, and do measurements and do tests in a real world prototype. And then we also would loop back to the theory and the analysis and the simulation if we see some problems along the way. So this back and forth between these three important components really are the fundamental philosophy that we take in our wireless research in LICAN. As for the specific research topics, we are interested in 4 different aspects. Wireless communication is more on the physical and MAC layer side, where we are interested in mostly in the multi-antenna systems, MIMO transceivers. We're looking at signal processing techniques, and as for the applications, we consider millimeter wave, Internet of Things, and 5G. For wireless networking, we are looking at more optimization problems, where we focus on how can we improve the network performance by optimizing, for example, the network operational parameters. Mobility is a good example. How can we, for example, optimize the mobility parameters to get a better handover success rate? We are also interested in dynamic spectrum access as well as ultra-dense small cells. The third is, as I have mentioned before, machine learning for wireless system design. In this direction, we are interested in using machine learning techniques such as deep learning and reinforcement learning to solve challenging wireless problems. Last but not the least, we are interested in wireless prototyping. Right now, we are developing a software radio testbed to support the previous research efforts I have mentioned. Additionally, because our lab is also interested in machine learning research, we are also currently building a communication and machine learning joint testbed that will support our research for machine learning as well. So the second thrust is on the machine learning side. So what do we do there? Again, we focus on 3 different sub areas in the machine learning research. The first is about reinforcement learning, especially on multi-arm bandits. We have been working on bandits for quite a few years, and we are interested in developing bandit models, bandit algorithms, and their analysis. This includes contextual bandit, multiplayer bandit, and the bandit with adversarial attacks. These are our current focus. The second direction is machine learning methods for medicine, especially for clinical trials. This is at least partially motivated by the ongoing COVID-19 pandemic, where we have seen that conventional clinical trials are not very efficient in terms of the time it takes to complete the trial. So we are advocating for more dynamic, more adaptive clinical trial methodology design, leveraging the tools from multi-arm bandit and Bayesian inference. The third direction is distributed machine learning, in particular federated learning. Our interest, however, is more on federated learning in wireless. So we're considering a federated learning scenario where clients are wireless devices, such as IoT devices or mobile phones. and the parameter server is the base station. And we are interested in understanding federated learning over the wireless edge. For this area of research, our outcomes are primarily publications in the top tier machine learning and AI conferences. We have been publishing extensively in these conferences, NeurIPS, ICML, Triple AI, AI Stats, and EGCA. And you are welcome to check out our publications from our group website. So this is a very brief introduction of our research lab and what our current research focuses are. If you are interested in our lab, please feel free to reach out to me. In this slide, you will see my email as well as my research website, and where you will find more research details. You can also contact me via Twitter or Skype. Lastly, because of the ongoing pandemic, I'm not really physically on campus. But if you want to see our lab, if you want to have a tour of the lab, talk to me or talk to my students, feel free to email me, and we can set up an appointment for you to come over and visit us. Okay, that's all. And again, thanks for stopping by. I look forward to meeting you.